Okay, so this is a video to outline the iron fertilization experiment. I'm going to go over the materials and the process that you use the materials and what order you would use them in. This is just a general guideline. Students should develop their own way of doing this and the amounts of water and air and stuff that they would use in the time that they're going to run the experiment for. So right here, what we have is the first thing you're going to need is a tank to grow the diatoms in. Our diatoms should be arriving by Wednesday of this week. Today is Monday. You need a light in which to grow the diatoms because they're photosynthetic. And I have a power head in there to move the water around. You can probably also put a bubbler in there to add oxygen to the water, to oxygenate it so they have oxygen that they need. And then you can also put a temperature if you want to, something to raise the temperature, like a heater, if you want, although I don't think we've ever used it before. I don't think we need it. So these are the jars we use, Kupek jars with the lids that have been modified for our use. So basically these are little pieces from Lowe's or Home Depot for irrigation systems. There's just little tabs, valves, and then little hoses. So basically, first thing they're going to do is they're going to get some jars. I recommend no more or no less than 3. They're going to have 1 that could be their control, and then 2 other that they're going to change the amount of iron in. Oh, I need to get iron. So then what they're going to do is they're going to take some of the diatom water and measure out a very precise amount, put that in the jar, and then they're going to add the iron, which I don't have with me, into the jars in a certain amount, a certain measured amount. We've done iron powder in 1 gram and then 2 grams, or you could do iron sulfate, 1 milliliter, 2 milliliters, however much you want to use. Once they've done that and they've secured the lid, so they have their control and their other jars, they're going to come over here. This is our iron setup, our carbon dioxide tank that we have set up. It was dropped recently, but here's what it looks like. We have the balance, so it's 2.5% and a balance of nitrogen, so it's close to the atmosphere. And what they're going to do is they're going to open one of the valves on top, and they would stick this on top of here, like so. Then they would open the valve up here, and they would time it for a certain amount of time. We usually, I think, about 5 seconds to flush out all the air in that headspace, which the headspace is going to be that space above the water, to flush all that out so that you get most of what's in there is going to be this 2.5% carbon dioxide. Once they've done that to all 3 jars, we're going to put them up here on like a wire shelf. Up above will be lighting to help the diatoms be photosynthetic. You're going to run it for a certain amount of time, 10, 15, 20 minutes, 30 minutes, an hour. They can do longer ones than this, but usually they use up the carbon dioxide pretty quick. Once you run out of your time, come over here. You can grab a syringe. You take the syringe, put it on top, pull out the headspace. It's hard because it's going to create a vacuum, but we go to about 30 or 40 mils. We have a Quantec machine. This is a carbon dioxide analyzer from Quantec, and put it in there. When it's on, squeeze it in, and then it will tell you the percentage of carbon dioxide you can take as a reading. And that's where you get your measurement for each of the controls and the experiment. Other ways you can run this, if you don't have an analyzer, you can randomly do counts of the water and count the number of diatoms to see if there's a change. It takes lots of counting and lots of random sampling of that. So it's more difficult, but if you have kids, they can pull lots of drops of water out. If you have microscopes, they can count. So anyway, so that's just a slight overview of the procedure. All the procedures will be much more in depth because the kids have to come up with ways of how are you going to put the water in, how much, what are you going to do beforehand, how much CO2 you're going to put in, how long, how are you going to close the valves. All those different things take lots of procedures in and among themselves. So anyway, hopefully this helps on doing this experiment. Thanks.